Hello everyone, I wanted to do a video walkthrough of one of these frappies. Who knows, maybe I'll have time for two, but at the very least, I'm going to do one of them, and hopefully seeing me do these things and my thought processes will help you. Anyways, here we go. It says show all work, indicate methods using, the normal stuff. It says 2 statistics students went to a flower shop and randomly selected 12 carnations. When they got home, the students prepared 12 identical vases with the same amount of water. They used 1 tablespoon of sugar in 3 vases, 2 tablespoons in 3 of them, and then 3 tablespoons in another 3 of them. And the other ones, they put 0 sugar. After they were prepared, they randomly assigned 1 carnation to each vase and observed how many hours each flower looked fresh. And here's a scatter plot. So it asks to briefly describe the association. Okay, so describing the association, to me, first of all, that reminds me of the 3 things we're supposed to talk about, because there's always 3 things. It's form, direction, and shape. I feel like that's wrong though. It's supposed to be strength, direction, and form. There we go. That's better. Form, this looks pretty linear. So this is definitely linear. The direction, it is going up, so it's positive. The strength, it looks pretty strong to me. I'd say it's looked pretty strong. So that's my thought processes there. The shape, the strength, and whether it's positive or negative. So I'm just going to do this, and I'm going to make sure to put it into context. The association between sugar and freshness length, I guess. Is a strong, positive, linear relationship. Okay, something like that. Doesn't have to be word for word, but just something like that. The big thing is that I am putting it in context. I have said it is strong, positive, and linear. That's the main things. Okay, so that's it for that question. Describing association, 3 things. It now says the equation of the least squares regression line for the data is this thing. Interpret the slope of the line in context of the study. Okay, so interpreting slope. Slope is the one where it's supposed to be, I'm describing it as something increases by 1, then the other thing's going to increase by whatever the slope is. So in this case, the slope is 15.8. I already forgot the context. I think it was sugar and freshness. I'm just going to put this here to remind myself. Interpret the slope. Okay. For each increase of 1 tablespoon of sugar, it is very important that it is always 1 tablespoon or 1 pound or 1 of whatever it is. But the number 1 is necessary for full credit. For each increase of 1 tablespoon of sugar, you would expect on average, or something like that. You can say an estimate, you can say on average, something that is non-deterministic. You do get points off if you say it is or it's going to be. None of this is a perfect equation. It's just, a least squares regression prediction line, right? This whole thing means prediction. So you have to put something in it that shows that it's not going to be exactly 15.8, but it's going to be something like it. So on average, you would see this or something. You would expect on average, let's see, it's a plus sign, so it'll be an increase of 15.8, whatever this is, hours of freshness, of 15.8 hours of freshness. Boom. And you know, you could have put on average back there if you just forgot it. You would expect an increase of 15.8 hours of freshness on average, you know, or you would expect an estimated increase of ba-ba-da-ba-da, whatever. So there are different words you can use, but it's just something like that. The big thing is it has to be 1 tablespoon, the non-deterministic thing, and of course context, including the correct number. If you use the 180, obviously you'll get it wrong. Next up, calculate and interpret the residual for the flour that has 2 tablespoons of sugar. Oh boy. The flour that had 2 tablespoons of sugar and looked fresh for 204 hours. Okay. Let's see. Residual. If my pen decides to work, it's deciding not to work. Residual. Hey, look, it's another pen that doesn't work. Equals observed minus predicted. That is the formula to use. Observed minus predicted. And the 2 tablespoons, 204. So that means 204 should be the observed. Where is it? 204 for the 2 tablespoons. So this was the 2 tablespoons. 204 was this one right there. So it's saying for this one right here, the actual was 204 minus the predicted. So I'll go ahead and I'll do the predicted work in red. It's just the predicted is the Y with a hat on it right here. So 180.8 plus 15.8 times X. And the X in this case was 2, right? It was 2 tablespoons, and then they observed 204. So the X is 2. And if you plug that in, I'm just gonna grab a calculator real quick. And I'll do a pluggy chug. 180.8 plus 15.8 times 2. Boop. So I got 212.4. So this will be 212.4. So 204 minus that answer is negative 8.4. So calculate and interpret. That is the calculate. This is the residual. Negative 8.4. Okay, interpreting, that's dealing with the whole negative value thing. They're asking you to compare it to the predicted. Because this is negative, it does mean the observed thing was less than what was predicted. So you would have to say that. You'd have to use the word less than specifically. So the observed, what's the context? The observed number of hours that the flour looked fresh was 8.4 hours less than expected or predicted. You could use expected or predicted. It's just, once again, you have to have the right number, you have to say it's less, and you have to use non-deterministic kind of stuff. Because, you know, the y hat is a predicted value. Okay, finally D, suppose that another group of students conducted a similar experiment using 12 flowers, but included different varieties in addition to carnations. Would you expect the value of r squared for the second group stated to be greater than, less than, or about the same as the value of r squared? I don't think it's really necessary for this question, but I'm just going to notice that we did say that it was strong, which means r is strong. That's the correlation. And if r is strong, then that means r squared is also going to be strong. So I'm going to know that it is string. So when you use just carnations, it's pretty strong. If you start using other flowers in addition, that's like increasing a lot more variables, because now it's like, well, some flowers might do better and some might do worse. So it's going to make it a lot more variable. And if things are more variable, then it's probably going to be less strong. Like, there's technically no way to know for sure, but it is very likely that the pattern is going to get worse. So the r squared would go down. Would you expect it to be greater than, less than, or same as the value of the first group? It would be less than. And then we have to explain it, of course. I would expect the r squared value to go down because, so first of all, down, because with different types of flowers, there will be more variables which will likely decrease the strength of the previous relationship, or something like that. Most likely they're not going to be super specific on that kind of wording, as long as you, of course, correctly say it's down, and you somehow are saying that because there's more flowers, there's going to be more unknowns, and, you know, having the amount of knowns means the relationship's going to get kind of hazy, and meaning r squared would go down. Or, you know, you would say that the new groups would be less than the first groups. I just used down, but you could use the less than when comparing them. And that's it. I think that's it for that crappy. So, okay, hopefully this helped. Take care. Bye-bye.